In this lecture, we're going to make use of the continue keyword to fix the calculator that we have built in a previous lecture where we were doing some practice with indefinite loops. Let's head to Visual Studio Code and do this. Here we are in Visual Studio Code. The current project is Fix Calculator because that's what we're going to do. We're going to grab our template files. We are going to open this in Visual Studio Code. We're going to do Open Folder. And we're going to select Fix Calculator, and this is going to open up. We're going to open up our main CPP file, and we're going to take out whatever it is we don't need. So what I am going to do is go and take the code for the project where we designed a calculator to practice indefinite or infinite loops, and I am going to put the code here, show you the problem with it, and we're going to try and fix that with the continue keyword inside our loop. You can get the code from the resource section of this course, or you can even download the source code for the entire course and track down the code for this lecture and use that here. Do whatever it is helps you out. For now, I'm going to take out everything we have in here and put in that code. I had it on my clipboard, and it was a calculator that was basically doing operations like addition, subtraction, multiplication, and division. And we could run it. So let's actually try to build it. And we're going to run the task to build with GCC. The build should go through. And if we try to run it and run Rooster, it's going to tell you, welcome to Awesome Calculator. If you say you want to do multiplication, for example, it's going to say, give me the numbers you want to multiply. I'm going to say 5 and 8. And I'm going to hit enter. It's going to tell me the answer. I'm going to say I want to continue. We did this design a while ago. If you want to refresh your mind on how we did this, you can go back to that lecture and watch that. But for now, I am going to say that I want to do subtraction. So let's do that. And which numbers do I want to do the operation on? Let's say 45 and 8. And it's going to say 45 minus 8, it's 37. This program works really well. But what happens if we try and put in an operation that we don't support? Remember, we only support addition, subtraction, multiplication, and division. What if I don't even put in an operation and put in a number, for example? Let's try this. So for now, we're going to stop it, and we're going to clear, and we're going to run it again. So it's going to ask me what operation I want to do. I'm not going to put in any of these operations on purpose. I'm going to put in a 6, for example, and notice what happens. It's going to tell me, type in my two operands separated by a space for this operation I want to do. And this doesn't make sense. This is not an operation. How can I put in my operand? And this is a problem you might have in your programs if you're not careful. So it is really good to try and test your programs for input that might give it a hard time. And then you're going to try and fix these problems. So if we try and put in two operands, for example, 45 and 44, it's going to say 6 operation not supported. We are actually handling this problem, but we're not handling it at the correct place. We are waiting until we hit the switch block here, and it's going to see that we don't have an operation called 6 or whatever garbage we put in, and we're going to hit the default case and say operation not supported. That's what we have in here. And for the user to really stop this application is to persevere and put in input for an operation they really think is not going to work. And only then are they going to get a chance to stop the application. So we want to fix this. Let's stop this application. So it's going to say done, helping out by. And what we want to do is to test and see if the operation that the user has typed in is an operation that we support. And if it's not, we're going to tell them and close the application. I think that's a nice thing to do. So what we're going to do after we have the operation typed in, we're going to test and see if it's addition, subtraction, multiplication, or division. There are many ways one can do this, but this is how we're going to do it. We're going to say if operation is not equal to the plus operator, and we're going to say and operation not equal to the negative or the minus operator. And we're going to keep doing this. So let's say and And I don't want to keep typing this, so I am going to copy this and go down and put it one time, go down, put it another time. And I'm going to put in the multiplication operator here and put in the division operator here. And I think this should work. So we need to put our parentheses here. And we need another parenthesis here to make sure this is legal C++ code. Be careful about this. And if all these tests fail, we know that the user has actually put in something illegal. It's not plus, minus, multiplication, or division, and we are going to continue. So what this is going to do, it's going to skip whatever it is we are doing after in the body of the loop here, and it's going to go on the next iteration, and it's going to ask the user to put things in again. I think this is a better way to handle this problem. So we're going to say std cout operation, and we're going to say whatever operation they typed. So we're going to say operation here, and we're going to say not supported in uppercase so that they can see it. And we're going to say stdendl. And now we're going to go down and say continue. And it is going to continue. And the next time, if they try to type in the same thing, they're going to see this message. And the calculator is not going to do anything useful until they type something like this. And I think this is a better way to do things. So we're going to bring this up and build the application and try it out. And the build is good, so we're going to clear and run Rooster. So we're going to be asked the operation we want to do. We're going to put in a bad operation on purpose. So let's put in an opening parenthesis, and it's going to say operation. This here is not supported. It's going to ask me to type an operation again, and it's going to give me a nice message of the operators that are supported. So if I see that the operation is not supported, my mind should start looking for a piece of documentation on which operations are supported. And I'm going to look here and find these operations. And I'm going to say multiplication is supported. I'm going to type it in. It's going to ask me my operands. I'm going to say 6 and 8, for example. And it's going to multiply that and give me an answer, which is 48. And again, if I make a mistake again, let's put in an @ symbol like this. It's not going to be supported. Here it's saying by. So I didn't type yes, but we can try this out again. So we're going to run Rooster. And I am going to say multiplication, for example. I'm going to say 3 and 6. It's going to give me the answer. And I'm going to say I want to continue. If I put in something bad, for example, a percentage symbol, it's going to say operation percentage not supported. It's going to give me the documentation. And I'm going to type in a correct operation, for example, addition. And I'm going to put in my operands. And it's going to add those up and give me the result. And if I don't want to continue, I'm going to say no, and it's going to end and tell me goodbye. This is really all we set out to do in this lecture. I wanted you to see how we can use the continue statement to make this application here better from the perspective of how users are going to be using it. We are going to stop here in this lecture. The next one, we're going to see how we can pass initializers to a ranged-based for loop. Go ahead and finish up here and meet me there.